Have you ever opened up a project and just felt that sinking feeling? You're staring at this massive, tangled code base, and you just know it's going to be a tough ride. Well, you're in the right place. We're about to turn that fear into a real, solid plan for taming even the scariest legacy code. It's a classic developer nightmare, isn't it? You've got thousands, maybe hundreds of thousands of lines of code, zero documentation, and you're pretty sure if you breathe on it wrong, the entire system is just going to fall over. Trust me, we have all been there.
But here's the good news, you do not need to rewrite the entire thing from scratch. We're going to walk through 5 super common traps you find in legacy code and give you practical step-by-step ways to start making things better, like right now.
So, here's our game plan. First, we'll tackle a really sneaky bug that loses data when a user first launches your app. Then we'll get into a big architectural idea, composition over inheritance. We'll talk about why you should let your views be dumb. It's a good thing, I promise. And finally, we'll map out a realistic strategy for how to actually start testing and even how to test the code that feels completely untestable. All right, first up, a subtle but incredibly expensive bug. We're talking about losing your most valuable analytics, the data from a user's very first session. Think about it, especially for something like an e-commerce app, that's your most critical data, and it's just vanishing into thin air. So here's what's going wrong. It's basically a race condition. The app opens and your analytics SDKs immediately try to wake up. But oops, they need an API key from a server configuration, which the app hasn't gotten yet. The config arrives a split second too late, the SDKs fail to initialize, and boom, all that precious first launch data is gone forever. And the fix? It's actually beautifully simple. We just flip the order of operations. The app opens, and we immediately ask for the config. While we're waiting, any analytics events that fire just get put into a temporary little list in memory. Then, once that config finally arrives, we initialize the SDKs with the keys they need and flush everything we've been holding on to. Just like that, problem solved. No more lost data. Okay, let's pull back from that specific bug and talk about a bigger architectural choice that causes so much pain in legacy code bases. We're talking about how we reuse code, specifically the choice between composition and inheritance. So inheritance creates this really rigid is-a relationship. You're saying, my configuration API is a special kind of HTTP base. This locks them together, forcing your API class to inherit everything, whether it needs it or not. But composition creates a flexible has-a relationship. Your configuration API simply has an HTTP client. This is a game changer because it's loosely coupled, which makes it a breeze to test. You can just hand it a fake HTTP client in your tests. So here's the bottom line, the big takeaway here. Inheritance is a great tool for defining genuine hierarchies, where a poodle really is a dog. But if your goal is just to reuse some functionality, like making a network call, always reach for composition first. It's a small shift in thinking that will save you a world of hurt down the line. Now, let's talk about a classic legacy code trap. It's when our user interface, our views, gets way too smart for its own good. This all comes down to a fundamental principle that often gets ignored: separation of concerns. So let me ask you a question that gets right to the heart of the matter. Should a simple little component like a cell in a list be responsible for knowing how to talk to the internet, make an API call, and fetch its own data?
And the answer, I hope, is a big, flashing, emphatic no. A view has one job and one job only: to display data that it is given. It should be completely clueless about where that data came from. The network, a database, a local file, the view shouldn't know or care.
And here's why this is so important. The second that Vue fetches its own data, you've permanently welded your UI layer to your network layer. This makes the Vue an absolute nightmare to test. You'd have to spin up a fake server just to see if a label shows up correctly. So here's a great rule of thumb for you. If you ever find yourself typing import service at the top of a UI file, that is a major red flag. Okay, so we're seeing all these ways we could improve the architecture. We know we need tests to lock in those improvements, but where do you start? When you're looking at a giant project with literally zero test coverage, the whole task can just feel paralyzing. It's totally overwhelming. Here is the secret. This is the most effective strategy, period. You don't try to boil the ocean. You don't stop all feature development for 3 months to add tests. You just start small. The very next time you have to touch a piece of code for any reason, that's where you add a test. This becomes your new habit. Got a bug to fix? Awesome. First, write a test that proves the bug exists, a test that fails. Then, you fix the code to make that test pass. Building a new feature? Write the tests right alongside the new code. You just chip away at it, building up this safety net little by little, making the codebase healthier with every single commit. Okay, but what about that one class? You know the one I'm talking about. The one where some critical dependency, like an API client, is created deep inside a method and it just seems completely fundamentally untestable. What do you do then? Well, to solve this, we need to introduce a concept called a seam. A seam is just what it sounds like. It's an opening. It's a place where we can gently pry the code apart just a little bit so that we can slip something new in without having to rewrite the whole thing. It's our entry point for injecting a fake object or a test double during our tests. Check this out. This is a perfect example. On the left, our cell creates its own Search API instance right inside the load method. It's totally locked down, completely untestable. But look at the change on the right. It's tiny, but it's everything. We add a static shared instance on the Search API itself. Now our cell just uses search-api.shared. That is our seam. Because in our test file, we can now just say search-api.shared equals mock search API, and we have full control. And I gotta tell you, this is a super important mindset to have. Is a mutable, global static property the absolute pinnacle of perfect software architecture? No, of course not. We know that. But that's not the point. The point is, it makes the code testable today. Sometimes you have to accept that the code might get a little worse on its journey to getting a whole lot better. It's about progress, not perfection. So really, the biggest thing I want you to take away from all this is to just think small. Don't get paralyzed by the size of the whole project. Forget about refactoring the entire application. Instead, my challenge to you is this. What's the one small, testable, positive change that you can make in your codebase today? Because that, right there, is how you really win the war against legacy code.